Hello, my name is Brandon Taylor, and tonight I'll be presenting on the ANOVA model. An ANOVA test is a way to find out if a survey or experiment results are significant. In other words, they help us to figure out if we need to reject the null hypothesis or accept the alternate hypothesis. You are essentially testing groups to see if there's a discrepancy that exists between them. Examples that you might want to test for different groups are if you have patients that are trying different therapies. For mental health conditions, you could have counseling, medication, and biofeedback. So we want to see if one therapy is more effective than the others. A second example would be a tire manufacturer has two different processes to make tires, and we want to determine if one process is better than the other. Another example could be students from different high schools take the same exams. We want to see if one school outperforms the other. There are a couple different types of ANOVA test, and the first is a one-way. There's a one-way and a two-way. One-way or two-way refers to the number of independent variables. So that is really where we determine what type of ANOVA test we're going to be using. And it comes down to the independent variables. In your analysis of variance test, okay, or the ANOVA, one-way has an independent variable with two levels. Okay, for example, brand of cereal, which we'll talk about in a minute. A one-way ANOVA between groups is used when you want to test two groups to see if there's a difference between them. So again, we're looking at two groups and we're looking just at the differences. A one-way ANOVA is used to compare two means from two independent or unrelated groups. And what we're looking for here and what we're using is the F distribution. The null hypothesis for the test is that the two means are equal. Therefore, a significant result means that the two means are unequal. So when we're looking at comparing those different types using F distribution. What we're really looking for are there significant discrepancies there. A two-way has two independent variables. So obviously, as in the one-way ANOVA had one independent variable. We're looking at two independent variables, okay, and it can have multiple levels. For example, the brand of cereal and calories. Very, very standard kind of explanation for that. A two-way ANOVA without replication is used when you have one group and you're double testing that same group. For example, you're testing one set of individuals before and after they take a medication to see if it works or not. A two-way ANOVA with replication, two groups and the members of these groups are doing more than one thing. For example, two groups of patients from different hospitals trying two different therapies. And a two-way ANOVA is an extension of a one-way ANOVA. With a one-way, you have one independent variable affecting the dependent variable. With a two-way, there are two independents. So those are the two things to really understand the differences there. And we use a two-way ANOVA when you have one measurement variable, and that is a quantitative variable, and two nominal variables. In other words, if your experiment has a quantitative outcome and you have two categorical explanatory variables, a two-way ANOVA is more appropriate. And you can see it here in the chart where we're looking at male and female as terms of the patients, and then drug A or B, C, and D rather in the categories there. So drug 1, drug 2, and drug 3. Very basic explanation there of how you can see the different variables in action. Groups or levels are different groups within the same independent variable. So in the above example that we talked about earlier, we're looking at brands of cereals. And those might be Lucky Charms, Raisin Brands, or Corn Flakes. And so that's a total of 3 levels. Your levels for calories might be sweetened and unsweetened. And that's a total of 2 levels. So that's how we can determine that. So the example that one of the examples that I found was, let's say you are studying if an alcoholic support group and individual counseling combined is the most effective treatment for lowering alcohol consumption. you might split the study participants into three groups or levels. So medication only, medication and and counseling only. So that's how we can determine our different levels. And then the dependent variable would be the number of alcoholic beverages consumed per day. In a one-way ANOVA, variability is due to the differences between groups and the differences within groups. In factorial ANOVA, each level and factor are paired up with each other, or they're crossed. The below graph does a pretty good job of explaining how you can how those are crossed. So let's say you're running a two-way ANOVA to test male and female performance on a final exam. The subjects had either had 4, 6, or 8 hours of sleep. So your independent variable 1 is obviously the sex, male and female. Your independent variable 2 is 4, 6, or 8, and the dependent variable is the final exam score. So what was the final exam score there? And that represents our dependent variable. So this has been the ANOVA method of